Hi, can you hear me? I don't know, Siddharth, can you hear me?
Yes.
Okay.
Good evening, sir.
Hi, good evening.
And I couldn't attempt all the problems, but I attempted some problems of algebra and combinatorics.
Okay.
Like I was not able to get, like I solved the first one of algebra complete. A1 I could solve.
Okay.
In others, I got some rough ideas and like I was able to solve partial problems. Like in functional equation, I got the solution to one case, but
Okay.
the second case and like that. Like I made
Okay.
progresses in some problems, but I couldn't to complete them.
Okay. Actually, A2, I think we had discussed in one of our regular lectures. Do you remember? Because this equation looks familiar to me. I think you can go back and watch one of the lecture recordings. I think you may find it somewhere
Okay, so I'll check.
because it looks familiar to me. Apart from that, any other question where you are stuck?
No, sir. Like in the A2 one, I got one solution.
Okay.
Like I was able to get the solution of like I assume that if there exists some t such that f of t is equal to 0,
Yes.
then I was able to prove that the function is no, still I was able to prove that for all I greater than equal to -2, the f of I is I plus 1.
Right.
I wasn't able to proceed below -2.
Yeah. So, I mean, now I remember even when we had attempted the problem earlier, right? We had got stuck. Even I had to take some hint from the official solution at one point. But the important step, I mean, just to give you a hint, without asking you to look at the official solution, basically at some point you have to prove that f is a linear function, and that comes down to showing that the difference of two consecutive terms of f of x plus 1 minus f of x is a constant. If you prove that, then it will imply that it's a linear function, and then you can assume some structure like ax plus b and finish that problem. So the crux of the matter is how can you compute this difference of two consecutive values, f of x plus 1 minus f of x. If you can compute that in two different ways and equate the two, that is one possible idea which you can explore and see if you can make progress with that hint. Otherwise, you can borrow some hint from the official solution.
Yes, sir.
But yeah, but I'm quite sure we had done this problem earlier. I remember it. Okay. So for others who have joined, so any general ideas, which questions you are able to attempt and which ones you are stuck? Any question you need help?
For the A4 thing, I wasn't getting the motivation behind the official solution.
For A4?
Huh.
Okay. Yeah, actually, I have not reached A4 myself. So I have only done A1, A2, G1, G2, first two problems of every topic. But A4, I will take a look.
For A4, I got one solution, f of x is 2 minus x.
Right, okay. And I mean, the obvious identity function is also there, right? Because we can have everything as just cancel all the f, you'll get an identity.
Yes, sir.
So, yeah.
Like I did not get that function, but
Okay.
I got the case where f of 0 is not equal to 0, then f of 0 gets cancelled from both the sides. And then you get f of x is equal to 2 minus x.
Okay.
So like for the identity, I did not get because then f of 0 equal to 0. So I could not solve that case.
Right, okay. So in a question like A4, right, I think one of the important things you have to use is the idea of a free variable, which is that there are, broadly speaking, you can classify functional equations into two categories. One is where all the occurrences of the variables are inside f of something. So where it's very hard to manipulate and get the thing as f of x equal to something which does not have the function f. Whereas here, if you see the equation, the RHS itself has like x, which is like where value of x and y, which are exposed outside the brackets. So those kind of I don't know what if free variable is the technical term, but So the idea is that if you can manipulate the equation so that everything else is zero, then you have f of something equal to something which doesn't have the function f occurring anywhere. So that is one possible direction in which you would like to move. One more important thing to keep in mind, this is f of r to r. So it's quite clear that induction kind of approaches are not going to work. So it's, I mean, given the domain itself, it sort of restricts what are the possible things that you can try. So, but I have not attempted the problem myself, so I cannot comment much on it. Anybody else who has tried A4 thoroughly, or any hint that you can provide? Okay, if not, then maybe I will also give it an attempt. But if I have any clue, I'll just post on WhatsApp. Otherwise, I'll suggest maybe after 1 or 2 days you can look at the official solution. And again, how you read the official solution is very important. Don't read the whole thing. Maybe read 1 or 2 lines. Try to take some hint. Because typically, I mean, most of the solutions, what they will do, they will present maybe some lemmas or some sub cases that if you read that lemma and then you can try to show that on your own. So you can try to take hint that way. So that is one way you can proceed. And also one more important thing for any question which you are trying, not just A4, but even other questions you may have tried earlier. Before you move on to the next question, try to narrow down the essence of that problem. That what was the main clue or hint in the question from where you could have guessed the idea. So that will be useful somewhere else. So even for A4, I feel that. So I'm just looking at the official solution right now, that there are 1 or 2 sort of, I would say, learning value kind of points in the equation, in the solution, where if we realize that this pattern is occurring in the particular example, then we will be motivated to think in that direction, something like that. So, but yeah, anyway, that is about A4. And anything that anybody wants to comment about A1, A2, because I mean, particularly, let me just say something about A1. Actually, my laptop is not tablet is not starting.
Sir, I have solved A1 by introducing a new sequence BK equal to K by AK plus 1.
BK equal to K by AK plus 1. Okay.
Like if you shift the sides of the given inequality, you get that K by AK plus 1 is less than or equal to AK plus K minus 1 by AK. So then if you introduce that BK, you will get that BK is less than or equal to AK plus BK minus 1.
Right. Correct.
And then you write down all those inequalities and add all of them. Then the like by the telescopic, the b's get cancelled, and you only get bn plus 1 is less than or equal to a1 plus a2 dot dot plus n. So now that's n by an plus 1 is less than or equal to a1 plus a2 dot 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 plus n. So then I prove for a1 and a2 of n equal to 2. So now the product a1 plus a2 plus dot dot n into an plus 1 is less greater than or equal to n. So now that product, if we make the product constant, then the sum will be minimum if both the factors come towards root n. So the minimum value of a1 plus n will be n, and so the minimum value of the whole will be n plus 1, and that will be achieved when all of them are equal to equal.
Right. So I mean, the overall approach which Arnav is mentioning, if you ask me what would be the starting point for somebody who has not thought of this idea, if you look at the original equation, right, I mean, the RHS K times AK upon AK square plus K minus 1. I mean, if you just imagine it reversed, right, the numerator instead of denominator and vice versa, it very much looks like the LCM of 2 fractions, right? Because in the denominator you have K times AK, and the same terms are appearing separately in the numerator. So that is exactly how when you add 2 fractions, the denominator will get multiplied and they'll get sort of cross multiplied into the numerator. So that is one possible hint that you can look at. But I mean, apart from that, it's like the idea that you are trying to look at this as the first and the last term of a telescopic sum. That is the important leap, I would say, that you have to imagine what will that telescopic sum be, such that everything else will get cancelled and you'll be left with just these 2 terms at the first and the last term. So that was the sort of insight that you can try to look for. So I mean, in some sense, this is you may be familiar with questions where you are given a series of summations, and that you have to somehow convert into a telescopic sum, and then on the first and last term you survive. Here is the reverse thing. Here the first and last surviving terms are given to you, and you have to guess what is the telescopic equation or series which will lead to this particular parameter. So that is how if you want to classify the theme of this problem, it is kind of a reverse telescope in some sense. Okay. One more way of approaching a question like this is that, I mean, clearly what is given is in terms of, I mean, the nature of that equation is ak plus 1 is greater than or equal to some other value. So it's obvious that there is no upper bound on how large the ak can be, right? I mean, you can choose ak plus 1 arbitrarily large and still satisfy the equation. So, I mean, in some sense, what we can talk about is the the best possible scenario where ak plus 1 is chosen to be as small as possible while satisfying the given condition. So then, I mean, some kind of induction approach can work, right? So assume that a1, a2, an already satisfy the given condition. Then we have to talk about the an plus 1. In what condition an plus 1 will also satisfy the same requirement. But of course, you cannot, in general, you cannot say that the given inequality is a strict equality. I mean, that assumption you cannot make, because if any one of the values changes, then it's a different problem altogether. So, I mean, quite possible that somebody might make the mistake of saying that let us choose ak plus 1 to be as small as possible, given that constraint. And then in the same way, I'll choose ak plus 2 to be as small as possible within that constraint, and so on and so forth. And if that best case scenario satisfies the equation, then in every scenario, it will get satisfied. But that is not necessarily true. So I hope somebody doesn't make that mistake. Okay. So I mean, this is a difference between what is called a maximal and a maximum set of conditions, right? So minimizing on just ak plus 1 is a maximal combination, but that doesn't guarantee that it is a global maximum. Okay? So just keep that in mind. Any other approaches for the easy problem, A1 or A2 also, if anybody else who has attempted A2?
I think I got something like f of x plus 2 minus f of x is some constant, and then I could just bash it and then.
Oh, okay, so you got f of x plus 2 minus f of x. Okay, interesting. Because I mean, the solution which I remember is that we were able to show consecutive, so f of x plus 1 minus f of x, we were able to simplify and get it somehow.
Sir, I got that f of x plus 1 is f of x, f square of x.
Yes, correct. So yeah, actually that is exactly what we have to use. I won't say anything more right now, but if you look at the official solution, or if you just go back and look at our previous lecture, I think you'll get the hint from there.
Yes, sir.
I also
So,
attempted problem 2.
Yes, go ahead.
So what I essentially did was I substituted f of x for y, and
Okay.
what that did is that it showed that the left hand side is equal to -1.
Right, correct.
So that means there is a value k for which f of k is equal to -1.
Right, correct.
And that value k is useful, and
Yeah, correct.
I substituted y with k after that, and
Right.
that gave me certain results, and essentially substitution after that.
Yeah, I think that value turns out to be something minus of f of 0, right?
Yeah.
For which that value is minus. I mean, that actually value doesn't matter. The fact that
Yeah.
such a value exists is more useful.
Yeah, only the existence
Yeah.
was required. That was just
Okay,
instruction.
yeah. Yeah, I think maybe Arnav, you might have also come across this step that you get some f of something equal to -1, and then
Yes, sir, I got f of -2 equal to -2.
yes, correct. Yeah, and I think the f of -2 equal to -1 happens to be true for both the solutions of that equation. So both x is identically -1 as well as x is equal to x plus 1. F of x is equal to x plus 1. Okay. So then moving to other topics. So anybody who has tried the combinatorics problem, C1, C2?
Yes, C1 I didn't understand.
Didn't understand. Okay. I mean, basically, you have a straight line of objects, and you are trying to take turns pushing one object. Unfortunately, my laptop, this is not starting, otherwise I could have illustrated it. Let me just share my screen with you. Okay, I hope you can see my screen. So basically, the given condition is that if you have two bulldozers over here, and assuming that this left one is larger than the other one. So let's say, for example, this is 2 and this is 1. So 2 means the weight of that bulldozer. So this bulldozer can push this bulldozer. And now if assuming that this is the last bulldozer in the line, so there is nothing after this. So which means that this bulldozer will be rolling off the street and out on the road. So basically what we have to find out is that there will be some town along this line. So if I mark all the towns as a cross, there will be some town which cannot be pushed out of this road. So I mean, almost I can compare this problem to, if you remember, standard pigeonhole principle kind of problem where there are n people standing around and each person shoots the person who is closest to them. Do you remember this problem? Then prove that there is some one person who does not get shot, something like that, if you remember. So in some sense, this is similar to that one. And so, I mean, did you have difficulty understanding the problem statement, or how do you start?
Yes, sir, problem statement.
Okay. I mean, can you explain what is the difficulty? I mean,
Like I didn't get the two cases, like what they said that the big bulldozer pushes the smaller bulldozer aside,
yes.
and the rear end is unprotected. So if that reaches that rear end, then it gets dismantled. Like I did not get what that means.
I mean, basically, if there is no other bulldozer after this, right? I mean, because they're in the straight line. So if assuming that all the other bulldozers are on the left of this one, so then when 2 pushes 1, so 1 will be sort of removed from the equation, you can say, because 2 can push 1 to the point where 1 is no longer on this road. So one will be thrown outside the arena, so to say.
Okay.
Okay. So maybe you can go back and read the
Yeah,
question.
I'll try.
It's not can be done. Okay. Anybody else who has tried and solved this problem?
Like just induction works.
Yeah. Okay. So
Yeah.
I mean, you have to prove that there is some particular town which cannot be displaced by anybody else. So yeah, induction. Okay, but let's not reveal the answer because if others have not tried it so far. But okay, induction is one possible idea in this kind of a question. The difficulty, if you're trying induction in a question like this, is that when assuming that you have solved a problem for n-1 case, and so there you already have a winner that okay, this is the one town which cannot be displaced by any other town. Now, when you add the nth bulldozer in the equation, not necessarily now it depends on the problem that adding that nth object can sometimes disturb the combination so much that effectively knowing the solution of the smaller part is not going to help you at all. So whether this question is of that nature, or there is a possibility to generalize the n-1 solution to the n solution. So that is
Like
one
just
important.
keep the like n the new one like outside the thing. Like
No.
if you are inducting with like n,
Okay.
and if it's 2 for n, then for n+1 you place the other one outside the first n.
Okay, or rather, you want to say that given n+1 bulldozers, you will remove the one at the last end.
Huh.
And so what you are left with is a n bulldozers for which you know the solution. Okay. And now having sort of re-added the new n+1 bulldozer, what do you do then?
Then I make cases on like whether the like say like the king bulldozer of the induction step like sweeps the last one or it doesn't. If it
Okay.
sweeps, then it's done. If it doesn't, then you just get that the other one sweeps the whole thing.
Okay. Yeah, actually, I mean, even my solution is using induction, but maybe slightly different starting point.
There are two ways you can solve this using induction that I tried. One is general strong induction, which is also mentioned in the official solution.
Okay.
The other way is what is another way. It has a lot of cases. So exactly as Siddharth mentioned.
Okay.
Yeah. So there are many ways you can solve this using induction.
Yeah, but I think pretty much induction is the only way to approach this, right? I don't know if there is any way of apart from that to directly get the answer for this question.
Walk maybe.
Yeah, because I mean you're talking about a very large number of combinations in terms of ordering, right? Which bulldozer is larger and smaller one. So yeah, I think this question does naturally tend to generalize that if you know the answer of n level problem, you can reuse that for n plus one level problem. But I think that something you have to discover by doing some small exercises like trial and error, that to actually see how the n level problem influences the n plus one level answer. But as I said, there can be questions like this where actually it doesn't really help at all to know the n level solution. N plus one solution can be completely different. So we have to decide that for each problem individually. But anyway, so I mean, Arnav, yeah, you can take a look at the problem statement again and then take another attempt at this. Okay, so that was C1. C2.
Sir, I got A and B both for odd n, but for even n I got only A. I could not get even n B.
Okay. So what is the answer for the even case, or rather for odd case?
For odd case, for both of them, you take a regular n gon.
Yeah, I mean, yeah, regular in one will work. For even case also, you can do the same thing, right? The only difficulty is that because we are talking about there is no clear center which can be
So
common
for
for all the
even
pairs.
A1 also like only n gon doesn't work for even A. So there you have to introduce like what I did was I introduced the center, then constructed some equilateral triangles, and
Okay.
then took the like then completed the problem.
Okay, but basically, I mean, what I would suggest is start with the regular n-gon and how it can be modified so that the even case can be resolved. So, I mean, you don't have to start from a completely different configuration because basically, regular n-gon almost completely satisfies the given requirement. So, with some small modification to that diagram, you can actually complete the problem for even also.
Yes, so like I wasn't getting if the B statement is true for even or it is not true for it.
Right. Okay. How do I give anything for this? So, I mean, at least for small cases, you must have tried and see that it is not possible to arrange it, right? So, for 4 or 6 points, you see that it is not possible to do that.
Yes, sir.
See, the important thing, I mean, just as a way of hint, which you can think about is that because for every pair of points A and B, we are trying to look for a third point, right? So if you have n points, we are going to get n choose two such possible pairs, and so n choose two such possible centers. If I call C as the center, so then basically and clearly the number of centers is going to be much larger than the number of points. It means that one point will get repeated as the center many times. So, I mean, try to think in terms of the multiplicity that, I mean, how many times is a particular point being chosen as the center, and that might lead you to some contradiction.
Sir, but then like how do we get it if M is the center of A and B and also C and D? Like then how do we like then pigeonhole won't work, right? Because if A and B and C and D both are the centers, then is M is the center of both A, B and C, D, then we can't say anything. Like it doesn't contradict.
No, I mean Actually, what I'm saying is what you're saying is for two pairs of points, A, B, and C and D. But in general, assuming that how many ever points you have, and if you're looking at which point has the sort of maximum number of times that it is the center. So if I call, let's say there will be a point which is the center of A1, B1, A2, B2, up to some AK, BK. So that point is the center of such K such pairs. And now, by the very construction of the problem, if AI and BI have that point C as the center, then AI cannot be matched with some other point. So basically, there will be a unique point in that other set BI for which AI and that. So basically, AI and BJ cannot have the same center. If AI and BI already have the same center. So that is the idea. If you can try to use somehow.
Like, how will we introduce the evenness?
Actually.
What do you mean by evenness?
I mean, the fact that this is possible to do for odd n, but not for even n. So that,
For that, you can do something like a double counting thing.
yeah, but now I don't remember why the evenness matters. I mean, what goes wrong in the odd case? Is it just a matter of like edge case that one extra pair is there in the case of even?
Because like if you have like two n vertices, then if you take one vertex, it can be like suppose like if you have two vertices A, B, and C is good if like C equals CB,
yes,
then a point is good at most n minus 1 times because of like the parity of
right.
2n.
Okay.
One gets left out.
Okay.
And it like you can't have PA equal to PB equal to PC because it's center free.
Right. Okay. Now do you follow what Siddharth is saying? I'm not sure myself, but I mean somehow
I got the idea, like because here, like an extra vertex will remain in the even case, because one we take up, others we pair, so one will remain. So
right.
the number of pairs will be one less than the odd. Like if we take the odd, then one goes away, so all others are matched up.
Yeah, correct. Something like that. Okay. Yeah, but anyway, I mean, I think if you not completed the solution, you can do it along these lines. But yeah, I mean, I think this is somewhat you can relate it to the maximal principle or extremal principle, that try to look for the maximum number of overlaps between the points where the same center is repeated as many times as possible. So yeah. So I mean, just to again classify, and I think one thing we need to do, all of us, is that when we solve the problem, before we move on to the next problem, try to learn as much as possible that what was the pattern in the both, what was the pattern in the question, what type of question it was, and then what type of solution or what type of approaches did work to solve the problem. So both of these things are important. And I think this is I mean, I would say it is called a C2, but actually it is worthy of calling C1 only, because the typical pattern of C1 kind of problems is that the case which satisfies the equation is very easy to guess. Like for example, the regular n-gon was the one which directly works. So almost there is no effort to prove that the regular n-gon does satisfy the equation. But a slightly harder thing to do is to prove the other side, that to find out the cases where it is not true. So in general, this kind of question does yield very well to almost like a Tonkes kind of approach. The obvious necessary condition is also sufficient. So this is almost of that category. Okay. Okay, this was C2. C3 again, as I said, I have not myself looked at C3, so I cannot comment on that. But we'll meet again on Thursday when we'll try to complete this 2015, the first 4 problems of all 4 topics. So 16 problems we'll try to complete by Thursday. And so basically after that, I mean, we'll set up this sort of weekly cadence of trying to finish one shortlist every week. Okay. So I mean, some threads have been sort of left halfway today. We didn't completely discuss that. That is fine. So again, as I said, the motivation of this is not to discuss every question in detail. We can do that ourselves. We need to discuss the top level ideas that how we approach the problems, what themes are repeating, and how we can use them in different problems. So the focus is on that more than the actual solutions. Okay. So then quickly going to geometry problems. So G1 and G2, did you do that? Anybody? So particularly for G1, I want to mention that this is a typical case of a standard triangle configuration, but extended with some properties. So it is like at a very basic level, you have to be familiar with all the. I mean, obviously, we all know the basics of 9-point circle, orthocenter configuration, etc. But here, what also need to know is the associated other uh, sort of derived objects. So, for example, in this particular problem, we have to look at not just the orthocenter, but all the circles passing through the orthocenter. So, and what are the properties of those objects? That is also important here. And generally speaking, G1, G2 pretty much come down to angle chasing of some kind. So, for example,
In first one, G will be the antipode of C, right? In circumcircle.
not in the circumcircle.
It need not lie on the circles.
It is.
The
It is
order
the
is not, the order is not AGBH, it's ABGH,
Oh,
not
yeah.
AGBH.
Yes, right. I missed that.
I mean, G is the antipode of C, not, I mean, not in the circumcircle, but in the, I mean, the circle with diameter CG, you can say, right?
Yes.
Because triangle CBG is a right angle triangle.
Yes.
But I mean, what I don't know what hint can be given for this question, because pretty much unfortunately I don't see any way to break down this problem. Contrary to what I say all the time, that you can break a problem into 3-4 smaller problems which everybody can attempt. But here that I don't see any clear point where, you know, if you achieve this sort of lemma, then that finishes the problem. It is pretty much the whole problem can be done in a single swoop. So there is not much kind of intermediate steps that you need to guess, that if you do this, or rather to convert the problem into one equivalent simpler statement, that is not possible here. So it is kind of what you can call a monolithic problem, where it is almost like a all or nothing kind of question. And questions like this also get graded that way, that very often there is no scope to define like a partial marking scheme, that okay, if you get steps 1 and 2, then you'll get maybe 5 marks and the rest will get full marks. It's pretty much all or nothing kind of a problem. So this does happen sometimes, or not too often, but you get these kind of problems where there is not much scope for partial progress. Okay, so I mean, just I think draw the diagram carefully. Make sure that you choose the most scaling triangle as possible, so that you can make the correct guesswork that what is the location of G exactly, and how does it relate to the original triangle ABC. So that is the main thing for this question. So actually, if I just look at the official solution of G1, right, I see there are multiple approaches possible. So one is using, as I said, that using basic angle chasing cyclic quadrilaterals, but looks like there is one more solution also there, which has some kind of ratio chasing. I see. I'm not read through it completely, but I think I need to look at this. Just a minute. No, I don't know. I need to read the second solution more carefully to understand what it is about. But looks like that there is some other alternate solution also using ratios or sine of some angle. Okay. Okay, so this was G1. What about G2?
So
Yes, go ahead.
I believe there was also this alternate solution using trigonometry.
Okay.
So trigonometry also works on this.
Yeah, I mean, we have a lot of angles here, right? Because basically we are
Yeah.
talking about multiple.
Like applying stuff like law of sines and all. I believe I don't remember. I did this problem a while ago.
Okay. Yeah, but I'm curious to know because finally you want to prove that 3 points are collinear. So how do we express that idea in terms of a trigonometric equation? That I'm curious to know. If you can write out, if you have your solution ready, or even later on, if you can write it out and send
Remember
it
the
to.
solution. I just remember this problem.
Okay, okay.
Yeah.
Okay. So actually, in this question, one hint, if anybody has not tried it so far, is that choose the extremal example. So I mean, try to imagine what will happen if you choose triangle ABC to be as right angled as possible or as isosceles as possible. So in these extreme cases where the problem statement becomes somewhat degenerate, it becomes easier to follow what's happening because I mean a question like this, there are too many circles in the diagram, right? So already it is very hard to figure out what are the intersection points, etc. So if you choose a sort of simpler subset, let's say you choose ABC as isosceles triangle, and then I mean half of the problem becomes kind of symmetric around the central axis. So then you can make some more better intuition about what are the various points of intersection, things like that. And then I mean almost as if treat the isosceles case as the simpler version of the problem, solve that completely first, and then come back to the original problem. Okay. That is one way of approaching a question like this. Because I mean, many often questions like this can be maybe the problem setter started with a simpler version and then generalized it. So that is how the questions can often be created. But yeah, I mean, we can use that to our advantage to solve the harder problems. Okay, so G1 and G2. Again, G3, G4, I have not looked at myself, so I need some time to understand it.
I have a like different solution for G4.
For G4, okay. Sorry, I mean, I'm myself behind here, so I don't know what is G4 about. Can you
Also
just
for G8, I have a different solution.
for G8? So any solution which you have apart from the official one, can you write them and post them on the group?
I'll try.
Yeah, okay. Yeah, I mean, if you even if you don't write it out in full,
Like I can sketch it or something.
Yeah, exactly. Please do that.
Right.
Okay. And I mean, I also make sure to mention it at whatever problem you are posting the solution for. So I won't open it accidentally before I attempt the question myself. Okay. Then finally, number theory. So N1. Okay. So actually, I find we're just looking at N1. I'm somewhat reminded of the IMO question this time because in some sense it was kind of similar in a sense that we had a greatest integer term which had to be made into an integer, right?
The functional equation one.
Yeah, correct. I mean, they didn't explicitly talk about the greatest integer, but that turns out to be one of the important ideas, right? To show the existence. Sorry, actually, my laptop battery is quite dead, so I cannot show you anything on paper, but maybe I'll just sketch it out later on and send it to you. Important idea in question like this is that because I mean, its first thing is clear that these A0, A1, whatever they are, so they themselves are all going to be rational numbers. So the fact that AK plus 1 is AK times the greatest integer of AK, right? So that itself, instead of writing it as AK, you can write it as some numerator series upon denominator series, like PK upon QK kind of thing, right? And so you can have to separate recurrence relations for the numerator and denominator themselves. So PK and QK can be treated separately. So in that way, you can bring everything into integer domain by basically every rational number can be represented as ordered pair of two integers, right? So that is how you can change the domain of the problem from rationals to completely to integers. And then the condition that the series A1, A0, A1, A2 has to have at least one integer term. That is nothing but saying that at some point the denominator has to become 1. So the QK, the denominator sequence, has to become 1 at least at some point. So in that way, you can completely rephrase the problem into pure integer manipulation. So
Yeah,
that
but
is
when we
one.
when we are taking the ordered pair, we should take a GCD as one, right?
We should take the GCD as 1. That
But
is
when we are getting the recurrence, like how should we compute the GCD? Because we will get P in terms of P and Q, so and Q again in terms of I guess Q only. So like how would you compute the GCD? How would you know that the GCD of PK plus 1 and QK plus 1 is 1?
So either we force that condition, or we even if we don't do that, if let's say we don't require the GCD has to be 1, then maybe another way of replacing the problem is that, I mean, the condition that AK is an integer is the same as saying that PK is divisible by QK, right? So I think both approaches, I didn't give it much thought actually, that which of those two will work out. Okay, but one more important thing is that here we have to only construct a possible sequence. Like basically, if the claim is that for every integer n, such a series does exist, then we just have to be clever enough to create the circumstances for which that condition will be met. So, I mean, this is a question where you have the full creative freedom to decide how you want to set up your starting point. So, I mean, clearly, once you define the starting point A0, nothing else is in our control. So it is like we have to choose the starting point in such a way that eventually the series will have the integer which we are asking for. So, I mean, yeah, but I understand what you're saying, Arno. So let me give it some more thought that how you exactly trap the GCD like condition into this. But anyway, that was my idea. I think if you look at the official solution, there might be other approaches also. We don't rely on the separation of numerator and denominator, but that is one thing you can think about. Okay. Does anybody have any other approaches for N1 which are worth
Like one approach is like I don't remember exactly, but something like if you like mu2 of that like decreases like in like after every term, and then like you have some sort of infinite descent, and then you get a contradiction.
Oh, no, what decreases? I don't hear you.
mu2 of something. I don't remember exactly.
U2, what is that?
No, the periodic no.
Oh, okay, okay.
That's it. I think like what happens like you are able to prove like like all powers of 2 divide a finite number. Like you
Okay.
prove something like that. And so that number must be 0.
Okay, so and basically after some point all the powers will be exhausted and therefore will be forced to have an integer term, something like that.
Yeah.
I see. Okay. Yeah, I don't know if this is also covered in the official solution, but if not, then that will be one more approach for us. Okay. But anyway, I think we are close to the end of the meeting. So I'll suggest that when we meet on Thursday, we'll try to finish all the aspects of this discussion so that I mean, I will suggest for everybody that any problems which you have not attempted so far, you try to do those, and maybe after 1 or 2 days, you can start to take help from others. So you can ask each other for more hints. You can look at the official solution for some guidance if you are still stuck. So in general, this kind of 4+3 pattern, I hope that works out for you, that for 4 days you try the problems without any help, and then for 3 days you can take each other's help and try to work towards the solution. Okay. And we'll keep making progress in this way. Maybe we'll adjust some things over time, that what if I don't know if this is the best format to conduct these meetings, or we should go deep into discussing a few problems in detail, which of course will take more time but might be more valuable also. So I think we need to reevaluate if required. Okay. But okay, thank you everybody for joining, and we will meet again on Thursday. In the meanwhile, as I said, see, WhatsApp group is open for you to post also. You don't have to wait for the meeting. If you come across some difficulty, you want help, you can immediately ask on WhatsApp. Others can comment. So you can keep the discussion ongoing on the WhatsApp group. Okay. Okay, I think that's all done. Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Bye.
Thank you, sir.